There we go. Okay, so now we're recording. Okay, so we've come a long way here in terms of, even in a short amount of time here, where were we wrapping up yesterday is we were taking a look at and finishing up this notion of complex numbers, kind of getting used to it. That's the square root of -1 and kind of identifying the pattern, I squared, I cubed, I to the fourth, and then utilizing our work on multiplying binomials, and then also the quotient rule and product rule. That's all that stuff still comes into play with that. So we'll wrap this one up, and then we will kind of go back to just kind of taking a look at the review, the factoring techniques. That's really more of truly a review, because there are no more factoring techniques. It's just taking the factoring techniques and kind of putting them together, if you will. Okay, so with that in mind, let's finish this one up. See. Hit continue. I think you should pick us up where we left off. It did. Okay. Let's skip that one. Let's see what else we got. So this is, this is why I don't sometimes like the practice, because it gives you the difficult problem first and the hard and the easy problem later. So that's the only drawback to that. But this one is of the thing that we did earlier, where you have to basically apply your process for multiplying binomials, which is what we call the FOIL method. When you're multiplying binomials, that is the FOIL method. I tried to resist it, but we're full on with FOIL, but we'll see a more generalization. So just remember what FOIL means: first, outer, inner, last, meaning the terms that you multiply. So here we're going to multiply the first ones first. 5 times 8 gives us 40. Then we do the outer, which is the 5 times I, which is going to give us plus 5i. And now we do the inner, which is the -2 times +8, which is going to give us -16i. And then we do the outer, the last. I always mess that one up. -2 times I, which is going to give us -2 times I squared. And fundamentally, the thing to also incorporate and remember is, even though I has a specific meaning, we still treat it like a variable, combining like terms and whatnot. And so with that in mind, we do have like terms here in the middle. We're going to combine +5i minus 16i, so that gives us 40 minus 11i minus 2i squared. And then the only other thing that we need to do is that when you have an exponent over the I, we don't like that. It doesn't matter what the exponent is: I squared, I cubed, I fourth, I sixth, I 20 million. We don't like that. We got to we got to simplify it. And so that's where that clock comes into play. We have 1 here, we have I here, -1, and then, excuse me, minus I. Where on the clock is this? Well, the wheel, if we think of the exponent of 2 here, as 2 steps on the clock. So 1 step, 2 step. And so I squared, this is what I squared equals. It reduces down to -1. And so we're going to replace here the I squared with -1. And so then just bring everything else down. And so this gives us what? And now I'm going to switch over to typing because my handwriting is getting bad. 40 minus 11, 11i. -2 times -1 is +2. So we can add the 2 and the 40, and that's going to give us 42 minus 11i. And that's going to be the answer right there. Right there. Any questions on this process?
No, but could you leave that on there for just 1 second so I can finish copying it?
Sure. So just to keep in mind, the only new thing we're learning is this clock. This is the new thing right here. Just kind of where on the clock are you? And that's just to simplify an exponent over I. But in all other regards, you treat it just like you've done in the past with variables and like terms. Everything else, I think, pretty much runs the same. Um, they love to give you word problems. Sure. Okay. V I Z. Okay, but what it's going to boil down to, I is the amperage, so, and Z is the impedance in ohms. So this is telling you the amps, and this is telling you the ohms. So this is going to be I, and this is going to be Z, and so you just plug it in. Plug it into the formula right here. This is the formula that you need. And so plug in I and Z, and then you do your calculation. So this becomes 5 minus 6J. Now they'll use J, by the way. I'm glad they did this. J is the same thing as I. Okay, so you can use J, you can use I, and they probably want you to use J. So go ahead and use J. I forget about that. I grew up under the old school of I, but in the new school, and this started back when I was in college in the 90s, they started using J because J is sort of a little easier to discern between I's. I don't know. But it's still the same process. J is the same thing as I, just to give you a heads up. You can use J or you can use I. They both mean the same thing. But you just use the FOIL method to multiply the two binomials together. It's the same thing as the last problem, just put in a more word problem format, but that's what it boils down to. So it doesn't look like there's really anything new, except it's just more of the same. One thing here that's interesting, notice it starts out with a 12i squared on this one. You can multiply the binomials if you want. There's nothing wrong with that. You can start off with that first. But what I see here, one thing I recommend is take the I, oh, well, it's not multiply. You don't multiply. I forget, there's an addition between them. So this problem here is asking you to combine the like terms. Treat this as if it was you were adding polynomials because you were adding in the middle. I misread it. We're not multiplying. So FOIL does not apply, is what I'm saying. FOIL does not apply. You combine the like terms. Now you could go ahead and start combining like terms, and that's fine. But just one thing to keep in mind, and what may make the problem easier, is to just go ahead and simplify the I squared. Because remember, we don't like exponents over the I. So go ahead and simplify that. So if we do that, this first binomial becomes 12 times negative 1, which is what? Negative 12. So the first binomial changes to negative 12 minus 11i, and then you add the second binomial, 4 plus 8i. Oops. So all we did here was just take the I squared, simplify to negative 1, and and it changes that first term. And so it makes the combining of like terms a little easier to do, a little more straightforward. Questions on that?
Just finishing up.
And I encourage you, well, never mind. I'll save that comment. Okay, so then combine the like terms, and so end up, by the way, what you find, let me see if I can just put it back up there. You combine the like terms, negative 12 plus 4 is negative 8, and then negative 11 plus positive 8 is negative 3i. That's the answer for this one, just to give you a heads up. But all you're doing is taking your process for combining like terms. Again, I hate to sound like a broken record, but nothing new. It's all what you're hitting is sort of is you're taking old stuff and just doing it in a new way. What can we do with this one? We're multiplying radicals. There's two ways to go about doing it. Probably the more straightforward way. Well, I wonder what they do. Okay, hold on. I'm going to put it in the answer. Yeah, that's wrong. Here's what they want you to do. They want you to turn this into an expression with I, okay? So this becomes, remember, the square root of negative 18 is really what? I times the square root of 18. Where did the I come from? Do y'all see where the I came from? Where did the I come from? Well, keep in mind, negative 18 is really negative 1 times 18. Okay? So the I is really the square root of negative 1. So in other words, you can pull the negative outside of you can pull a negative outside of the square root by turning it into an I. By turning it into an I. So that's what they want you to do here, is turn this into I square root of 18 and then times, what would this become? The square root of negative 2. How would I write that using an I?
Just I square root of 2.
I square root of 2. Now you multiply. So we're going to multiply what? The stuff on the outside with each other. So we multiply I times I gives us what? I times I gives us I squared.
Yeah.
And then we multiply the stuff on the inside. Square root of 18 times square root of 2, we write as 18, put the 18 times 2 inside the radical. And so 18 times 2. Oh, no. I hit the wrong button. Okay, so let's take it all off. No words. I'll just rewrite it. Okay. So, here we go. I times the square root of 18. I times the square root of 2. Multiply the two i's to get I squared. Multiply the 18 and 2 inside the radical, but keep it inside the radical. And now, now you would look to ask yourself, can I simplify the square root of 36? And how will we simplify the square root of 36?
6.
6, yeah. So square root of 36 becomes 6, and we just bring that I from the outside and attach it to the front. 6I. Oh, whoops, wrong. Hold on. Remember, this is I squared. I forgot, it's 6I squared. I times I is I squared. Sorry.
Now we're going to get rid of the square on the I.
Now we got to get rid of the square on the I. So how do we do that?
You use your clock.
And where on the clock is it?
It's the second one, so it's a negative 1.
Negative 1. So now the final answer.
It's negative 6.
Negative 6. That's negative 6. That's the answer. Negative 6. And so let me try again. I'll try again. So turn the negative square roots into an I, pull the negative outside of the square root by turning it into I, then multiply the radicals, and then see if you can simplify the radical. If you can, simplify it. And so in this case, let's try again. Negative 6, submit answer. Yay, we got it. Okay, this is a good refresher. This is a good refresher. We have I to the negative 81 power. The first thing we need to tackle is what?
Negative sign?
Negative sign, right. We don't like negative exponents, okay? So how do we resolve the negative exponent?
You multiply a negative times a positive, so negative 1 with the 81?
Maybe. Let me type a rule here.
Okay.
What do we do with the negative exponent rule? What is that? This is actually pretty good because we need to start doing some review of the rules of exponents. So remember the product rule is same base, add the exponents. Quotient
Can you
rule is
bring it?
same base, subtract the exponents. Negative exponent rule says if you
Can you
have a
bring it
negative exponent, transport it to the other side of the fraction bar
to make it positive?
to make it. That's how we make it positive.
You
So in
don't
this
have a
case, we got to recall that this is really I over 1, and so you flip it over, and it becomes, so the negative exponent, you flip it, and it becomes I to the 81st power in the bottom. Now, from here, what do we do?
you use your clock.
Yep, you got to go. It's clock time. We don't like exponents over i's. So to resolve the exponent over the I, you got to find out where on the clock it is. And so we do that by what?
81 divided by 4.
And that gives us, I'll do it, 20
25.
remainder 1.
So it ends up as negative 1.
Which one?
Negative 1. It's the first one.
It, yeah, it's the first step, but that's I.
Yeah.
Oops. The first one is I. The second step is, so we're here with a remainder of 1.
So it's just I.
It's just I. So the denominator of I to the 81st power simplifies to just a plain I. And so this would be the answer, 1 over I. Questions on the process. And notice we're working a little fast, but really that's the only reason is because we haven't really learned. We're really doing a lot of review. Review of old stuff is coming into our new stuff. The old stuff on the rules of exponents, the old stuff on combining like terms, the old stuff on FOIL property, the multiplying binomials. The only thing we've really added to the mix here is the clock. Where on the clock are you? And the reason you do the clock is why? Whenever you have an exponent over the I, when you have an exponent over the I, you need to see where on the clock it is. Question so far? All right, let's keep pushing forward. Same thing, multiplying. There is a shorter method on this one, but if you just apply your FOIL process, it'll lead you to the right answer as well. So I don't I don't feel the need to muddy up your thinking. If you know how to do this one using FOIL, multiplying binomials, or distributive properties, we call it, fine, you'll reach the answer. But just remember, when you'll get an I squared, you got to turn that, you can't have exponents over the I. How about this one? This one's not really that different. It just looks different. Let me ask you, what's your sort of inclination on this particular problem, 6 plus the square root of negative 3, all of that squared? What's your inclination as to what do you want to do?
Take care of everything that are in the parentheses before you make 2 copies of it.
Okay, so how would you take care of, what would you propose?
I would start off by doing 6 plus I to square root of 3 first
Right,
to take out the negative sign and then go from there.
right. That is the right step. Take out that negative sign, turn it into I. And now that we've done that, let's go ahead and instead of squared, let's do our second copy. And then you multiply the binomials. You apply the FOIL method from here. The FOIL method. So the answer, by the way, just to help you all out, you all do the FOIL method on your own, but when we do this, we get 36 plus 2i square root of 3 plus 3i squared. Then you resolve. We don't like exponents over the I, so we got to take care of the I squared part. So when you take care of the I squared part, you bring everything down. So this becomes 36 plus 2i square root of 3. And then 3i squared becomes 3 times negative 1, which is 3. And then you combine the like terms, negative 3 plus 36. And that's going to give us 33 plus 2i square root of 3. So again, it's just really, you're just doing a lot of foiling, you're doing a lot of combining like terms, and that's it. So let me pause here. Any questions on working with complex numbers? I'm hoping you're seeing, and Jackie, it feels like you got a good handle on this, but everyone else, I just kind of want to check in with you. This is a rehash. This is a good review section because it requires all the stuff you've learned in the last 2 weeks. The rules of exponents, product rule, quotient rule, negative exponent rule, power rule. It requires combining like terms, multiplying binomials using the distributive property or FOIL, and then incorporates this. Any questions on, and simplifying radicals, square roots. Anything on that? Any questions so far?
Yes, on the problem we just did, right under the first, like the original problem where you wrote, um, you just foiled it, and that's how you got 2i square root of 3?
You
Or
talk
should
about from
I
here to here?
point it out?
Uh,
Yes, so,
yeah. So how
okay.
did I get that? That I actually used a formula, but I'm not going to bore you with it. You actually did it. If you've done the lesson titled Special Products of Binomials, this is called a perfect square binomial, okay? There's a particular way it happens, but yes, I did the FOIL because doing the doing the outers, doing the outers. Oh, I see. You're telling me I made a mistake.
No, not at all. I just was looking at that. I didn't notice anything
No, but
wrong.
you should be
I
telling
just,
me. You should be telling me I'm making a mistake because I did make a mistake.
you're lucky I didn't notice.
No, no. Basically, it's I can fix it. It's pretty easy. It's not a terrible thing, but
Do
basically,
you have to?
the outer is the outer is 6i square root of 3, and then the inner is also happens to be 6i square root of 3. So when you add those, it should have been what? Not 2, but 12i square root of 3. How did I get that? 6i plus 6i, just like you do like terms. When you add radicals, you just add the numbers in front and attach the common binomial, common radical, I mean. So 6i plus 6i is 12i. And so I need a 12 right here too. And I need a 12 right here. But yes, to answer your question, at the end of the day, you just apply FOIL.
Okay. Um, and then so when you multiplied, um, first, outer, inner. Okay, so when you did the inner, I to the square root of 3 times I to the square root of 3.
Oh, that's the last.
Oh, I'm sorry.
No, you're good.
That's
I just want to clarify.
yeah.
Yes,
Yeah,
it is.
you're right.
This one right
Um,
here times this
blah.
one.
Yeah.
So if I do that, I'm going to do it in green.
Okay, thank you.
So when you do that, the i's on the outside become I squared. I times I is I squared, right?
Hmm.
Square root of 3 times square root of 3, you multiply those 3's on the inside. And what's 3 times 3?
9,
9. And so then what's the square root of 9?
3.
3.
Okay. One moment, please. I'm going to take a picture of this because I wrote it out wrong. Okay. All right. Thank you so much.
Sure, sure. Okay. Let's shift gears and let's go to that factoring, the review of factoring. And again, this is going to be old stuff. I'm putting it here because now we're going to start a reviews. Okay, tonight this stuff is a good review. The complex numbers, a little bit of review on factoring. There it is. Wait, there it is. 3.R.7 review of factoring techniques, and this is also a review. But what it does is it not necessarily old stuff. Well, it is old stuff. So here, let me throw it your way. When we have four terms like this, how would we factor? Remember what we're trying to do. We're trying to break up at this point. Now we're trying to break up. How would we, when you see four terms, what method do you use? And so when you think factoring, you should be thinking GCF, greatest common factor, grouping method, trinomials, difference of two squares. Those are your four methods. Let me write that down. GCF factoring, grouping, trinomials, and then difference of two squares. Okay, grouping has four terms. That's the giveaway. Trinomials, how many terms? TRI means
3.
three terms. And difference of two squares, two terms with subtraction in the middle. Okay. So that's the giveaway. That's how you know which one you're going to be using. How many terms do I have? GCF can be used on any of them. So you always have to look for a GCF no matter where you're at. But for the other two, grouping trinomials and difference of two squares, it depends upon the number of terms. So if you're in a four-term situation, you got to use the grouping method. There's no way around it. So that's the decision point. So I'm going to do what? How am I going to do this? What's the grouping method? I'm asking you all questions because
Oh, for
hopefully by
this.
this point you finished that homework.
I know. You put parentheses around the first two terms and then around the second two terms?
Okay. And is there anything to sort of watch out for here?
The negative sign in the middle?
What do I do?
Or
How do I watch
I'll
out?
make that a 1.
How do I watch out?
You're going to make it a -1.
Where?
Where in between the parentheses.
Okay. Potentially, yes. But what else? What's the other thing?
You're gonna change the sign in the second pair of terms to a plus.
Right. So where am I going to look? What sign am I changing to a plus?
The 4x minus 32, it's gonna be 4x plus 32.
Boom. That's it. That's the thing. This thing now has to become plus. And why is that? Is because I separated by, hold on, my pen's not working. Here we go. By putting the parentheses right here, oh, I see what's going on. By putting the parentheses right here, in between the 4 and the minus sign, that required me to change that sign in front of the 32 to its opposite. Good, good. That's the thing that's really testing here. Not only do you know the grouping method, but are you keeping track of that sign issue? So now I have to pull from within this first set of parentheses from within this first set of parentheses, what's the GCF I'm pulling out?
Y.
Y. Okay, so what would that give me? I'm going to pull out a Y.
I'm gonna give you Y, and in parentheses it's gonna be your X plus 8.
I rip a Y out of each term, and it does leave an X, and it leaves an 8. And I bring down my minus from in between the two parentheses. So what's the GCF out of the second set of parentheses?
4.
So I'm going to rip a 4 out. Math is not very violent, but I sometimes use very violent terms. So when I pull the 4 out, what's left?
X minus 4. Oh, sorry, I was on the wrong one. It's X plus 8.
And if you're stuck, look to the first one as your guide. Because why? At this step, they should be the same. They should be. Okay. So now what?
You get X plus 8 in parentheses, and then Y minus 4 in parentheses.
We can take this common binomial and pull it out. Okay? And so that's exactly what we're going to do. We're going to take X plus 8 and pull it out. And what's left? The stuff that's in the front. The Y in front here and the minus 4 that is here. So it becomes Y minus 4. That's exactly it. So when it says factor, remember your decision tree. How many terms? 2, 3, or 4. 2, 3, or 4. That tells you what type of method you have to use. And if then you have to worry really about pulling out the GCF, because even the trinomial method you can use the GCF if you want. Okay, but that's what we're doing here, and that's how you know how you got to factor. So again, we have we have another 4-step. So apply the GCF, apply the grouping method again. Just be aware they're throwing this in here, not factorable. So that may be an option. This one, by the way, is factorable. So, but just to give you a heads up there. So let's see. When we take a look at this one, 7x to the third, parentheses 2y plus 7 plus 6b, parentheses 2y plus 7. What's the approach here?
Oh.
Just put the 7x to the third plus the 6. I can't.
Did
Plus the
did we?
6b in a pair of parentheses on their own, I'm gonna
Okay.
guess. Especially since the two other binomials are the same.
So what do we do with so is this the answer?
I mean, not just that, but also the 2x plus 7 in their own set of parentheses.
Right. Right. Yeah. So you factor out, you pull out that common binomial right here. Just like so basically this is the middle step of the grouping method. Right. So good. Good. Let's see what else. Now this is a trinomial. When you have trinomial, meaning 3 terms. So what's the questions that have to go through your mind? How do we know how to factor this? What method do we use? Because remember, trinomials had 2 different methods. One based upon the leading coefficient being 1, and one based upon the leading coefficient being something other than 1. So what's the leading coefficient here?
7?
That's why I wanted to ask this question. What does it mean to be the leading coefficient? And so what you do,
That I don't know.
you look at the term with the x squared. Okay? What's the value?
Okay.
That's the leading term. The leading term is the one with the highest exponent. So in this one, the leading the coefficient in front of that x squared is the leading coefficient. So we look for 1 in front of the x squared, essentially. So that has its own method. What's the method? And just to kind of go back to your notes, remember what it said. Step 1, write 2 sets of empty parentheses. Step 2, because it's an x, use the variable as the first term in each empty parentheses. And then step 3, look at the factors of the c term that add to the b term, the b value. And you just look at the numbers, 12 and -7. So what factors of 12 will add to give you 7?
Nothing.
Or I'm
3
sorry,
and 2.
is it 7 or is it +7?
3
So
and 4.
3 and 4, yeah. So come over here and list your factors of 12, okay? And put them as pairs. 1 times 12, 2 times 12, 6, I mean, 3 times 4.
I could have sworn you just said 7, right?
Well, no, you're looking at the factors of the
Okay.
last term that add to give you the 7.
So how does 2 times 6 give you 7?
It doesn't. So now you add the factors at this point. So find the values that
Oh,
multiply to
4
get
and
12.
3.
Right, and this is the one that you want. These are the
Okay.
factors you want. So +3 and +4. That's how it factors. How are we feeling on that one? It's probably been a couple days, but this is a good refresher. It's coming back because we're going to start using this stuff again. Factoring is going to be a part of our life for another couple weeks into November. Well, October and November as well. And then there will be a point where we don't do any more factoring until the final exam. Okay, here again. So strut your stuff.
Interruption. Speaking of the final exam, are we gonna have to take that at SOCC?
I
Are you not too sure yet?
No, I think it's going to be here. I'm
Okay.
not. We're not. We're fully online, so we don't have to meet on campus.
Okay, I was just wondering.
Okay. So here, this is another one of those problems that is, what's the leading coefficient?
So for this one, I just want to ask you before you say it. So A would be 1, right?
That is
And
exactly right.
B would be -3, not 3,
Yes.
right?
B
And
is the
C
value in front of the x, and it is -3, right? Just I'm
and
explaining as you go along.
okay, and C would be -18. So you keep all of the signs, right?
Keep all the signs. Yes.
Okay. And then you would do -6 plus 3, and that would give you -3.
Yeah. So let's go through the process. We have a leading coefficient of 1, so 2 sets of empty parentheses. Put the x first in each. Now find the values of the c value, which is -18. Find the factors of these. Well, -1 times 18, -2 times 9, -3 times 6. And then also don't forget about your other factors, your other set. +1 times -18. Just move that negative sign over. +2 times -9. And then +3 times -6. Which pair of factors will add to give you -3? Because -3 is what we have in the middle. Well, it's this one right here.
Yeah, so -6 plus 3. And that gives you -3.
So -6, right, +3, and there it is. Exactly right.
Okay. Is that like the only step? Or that is that simple, or I feel like I'm missing a step. No?
Nope, that's it.
Okay.
All right, so let's see another one because I think they're going to have it. Well, this is interesting. So let's factor this one. Let's do this one right quick. 45y squared minus 20x squared. How many terms?
Um,
How many terms does this one have?
2.
Two. There's only two terms, the 45y squared and the 20x squared. So which method would be possible?
Good GCF.
Maybe. Okay. Any others? When you have two terms and a minus sign in the middle, alarm bell should be going off.
Switch signs. That a squared minus b squared equals a minus b. That.
Maybe I missed something that you said. Anyways, let me resolve the mystery. When you see two terms with a minus sign, you should be asking yourself, hey, is this the difference of two squares? Maybe.
Oh yeah. So yeah, you did miss something. I did. Yeah. So that's still the same. Yeah.
So, but you should also be thinking at all times, hey, can I pull a GCF out? If you can pull a GCF out, do it first. Is there a GCF here on this one?
Yeah.
And it would be
45y squared and 20x squared. That is 5.
5. 5 is common. 5 is something that will go into, remember how you find your GCF. Look at the numbers first. Is there a number that goes into both the 45 and the 20? 5 is definitely one of those numbers. Now the variables, no. There's nothing in common with the variables. One is a y, one is an x, nothing in common. But we can definitely pull a 5 out. So when we pull a 5 out, what does that give us? I pull a 5 from the 45y squared.
9
Remember, you divide, and so you get 9
y squared.
y squared minus, pull a 5 from the 20 x squared,
4.
4, and don't forget your x squared, right?
Yeah.
Now look inside. So yes, the GCF method, we could pull out a GCF. Always ask yourself, hey, is there a GCF? A lot of times no, sometimes yes. Always got to ask. How about the difference of two squares? Look inside the parentheses. Is this thing factorable by difference of two squares?
Mm-hmm. Yeah.
Go through your checklist. Two terms, a minus sign in the middle. What about the first and the last? Are they perfect squares?
Yeah.
Yeah, the exponent of 2 is sort of the giveaway there. You see the 2's over the y and the x's?
Yeah, so it'll be 3y squared and minus 2x squared.
So I'm going to bring down the 5. Where are you? I'm going to bring down the 5. I'm going to rewrite 9y squared. I'm going to write it in terms of something to the second power. Okay? What to the second power gives me 9y squared?
3y squared.
Wait, say it again.
3y squared.
3y, all of that to the second power. That's going to be my f. Minus, how about 4x squared?
Is it 2x squared?
2x, right. And then all of that to the second power. And that's going to be my L value. So remember what we're trying to do. We're applying a recipe. Okay? So now we apply the difference of two squares method. F minus L times F plus L. So bring the 5 down in front. F 3y minus L 2x times F 3y plus L to X. And there it is.
Okay, yeah, that's what I got you. So that's the answer, right?
That is the answer.
So my question is like, how do you know when you're at the end? You don't ever know.
Well, you ask yourself, is there anything else I can do? You have to go through your methods. Is there a GCF I can pull out? Hopefully not, because the GCF should be the first thing you pull out.
Mhm.
And then you look inside the parentheses and say, well, look inside the parentheses here. There's only two terms, okay? So which of your methods has two terms, can be applied to two terms? Difference of two squares. Do either of those parentheses inside have a difference of two squares? No, because this one is a positive, this was an addition, so that's not, we need subtraction. And then this one here, these are not perfect squares, so we can't do anything more with it. So the way that you know when you're done is when you're done with your checklist, you look inside and say, okay, can either of these be factored further? Well, how many terms? And does it fit the paradigm? Does it fit the recipe? And they just don't. So because there's no other way to break it down, this is how you know you're done.
Okay.
It's pretty unsatisfying,
Yeah.
but I'll say for our purposes in this class, this is probably it. Once you break it up into binomials, the 3y minus 2x and 3y plus 2x, once you do that, you're pretty much done. You can pretty much count on it 9 times out of 10. 9.9 times out of 10.
Okay.
Okay, so that was a good one because it combined both the GCF and the difference of two squares. Here's another good one, and I'll do this one for you. Notice there's a 2. A 2 can be pulled out. The values are 2, 20, and 48. Those are all even numbers. So I can pull a GCF of 2 out. And so this becomes 2x squared minus 10x plus 24. So if there's a GCF, you pull out the GCF first. Now you ask yourself, can the inside be factored further? Well, how would we do it? It's got 3 terms, and the leading coefficient of that trinomial is a 1. Oh, so I apply my method. Empty parentheses, x is in front, and I look for factors of 24 that add to give me negative 10. Factors of positive 24 that add to give me negative 10. And those factors would be negative 6 and negative 4. So what we're showing you here is that you got to always be mindful of the GCF. Pull it out if you can. And if you can pull it out first. Because doing so oftentimes makes the rest of your factoring easier. This is the next one. Let's see. All right, how about this one? Factorable, yes or no? And if it can be factored, what is it? How many terms?
2.
So what method should you be thinking with 2 terms?
A GCF
Or
or
Difference of two squares.
difference of 2 squares. What you may want to do, and not that Addie, it's not you in specific, but if you ever have a doubt, write down the 3 terms, or 4 methods: GCF, grouping, trinomial, difference of 2 squares, because that dictates the way that they're different is the number of terms. So the way that you know which one to use is by way of the number of terms. GCF, always good. You're looking at that first, but then you have to see, do any of the other 3 methods apply? And so the way that you can knock out, it's only got 2 terms. Oh, the only one that could be possible, we don't know if it is possible, is difference of 2 squares. And then you ask yourself, does the difference of two squares even apply? And you would say yes or no.
I would say no.
Why? You're right. No. Why?
Yeah, I just don't see anything
Well, it's got two
between.
terms. Let's go through and so this is another checklist. Another checklist. Does the difference of two squares method apply? Does it
I
have
have
two,
No,
does it have
because
two,
it's
well, let's go through the checklist. Does it have two terms?
yes.
Are the two terms perfect squares?
no. Well,
Oh, yes.
Yes, they are.
Okay.
Is it a
Now
di- but hold
I'm
on.
gonna ask.
But hold on. Is it a difference?
no.
Oh, there's
No.
no subtraction sign.
Subtraction sign.
Ah,
That's what we're looking for. So my point and what I really want to draw out here is when it comes to factoring, you have to identify the method. That's not going to the directions on the test may tell you factor by grouping or factor by this. But if they don't tell you, they just say straight up factor, think of this in a checklist. You got your four methods: grouping, trinomial, uh, grouping, GCF, grouping, trinomial, difference of two squares. GCF may apply to any of them, so you always have to consider that one. But look at the other methods. Three terms, four terms, three terms, two terms. Ask yourself how many terms. Boom. That knocks out the other two. And then you ask yourself, does it apply? And so difference of two squares has a checklist with that. Two terms, perfect squares, minus sign. Has to have all three of those elements. If it misses one of those, doesn't apply either. That means you're left with no factoring methods. And so that means what? It's not factorable.
hmm.
So that's how when you go to factoring, you have to identify the number of terms that drives and tells you what method you can apply right away. How about this one now? Does this one have, is this one factorable?
Yes.
Okay, Addie,
Yes.
what method?
This would be
It is.
difference of two squares.
Yeah.
Two terms, minus sign in the middle, and they're both perfect squares. Bingo, bango, yes. It is indeed difference of two squares. So I'm going to let you do that one. But that's the idea here is you got to find out, you got to determine which method is applicable. And that's the purpose of this lesson. They're not telling you which method to apply, unlike the other lessons. And this is very much a good test, a good way on the test. This one here, we've actually already done one similar to it, the very first problem. What method would apply here? Or
Grouping.
potentially
Grouping.
grouping. Why?
Because you have four.
Four terms. Now it may not be factorable. You just have to go through the grouping method process to see if it's factorable. Okay? But the number of terms drives you which method you're going to use.
And it doesn't have any like terms, so
Right. Right. No, there's no GCF to pull out.
Yeah.
Okay. I hoped to have a review thing for you, but I didn't have it prepared in time. So what we're going to do, I have my other meeting here in a second. I have to take off for that. So we don't have class on Monday or Tuesday. Is that right? That's the fall break.
Yeah, that's fall break.
Okay. So work on your homework. Let me go to this. Wait, where are we? No words.
Hey, Professor, I have a question. So last night I wasn't able to complete one of them, but I did it this morning. I was
That's fine.
on overload. I'm not even gonna lie.
Oh, that's fine.
It will be points off. How many points does it take off if it's a day late?
No, you're fine. You're fine. Just
Okay.
get it in. I didn't get to this like I'd hoped. Well, let me say it this way. This part, this one, we actually already did. Okay, you just didn't realize we did it. The FOIL method, before we started using FOIL, FOIL is just the multiplication of two binomials. But before that, we did what? Take every term of the first parentheses and multiply with its own copy of the second parentheses, right? And then distribute. That's what 4.R.3 is all about. That's what it's all about. So these two, this is the only thing we haven't done right here. 3.R.10. Oh, well, I guess let me back up. The only thing we haven't done, and I'd hope to do, is these three. We can do that on Wednesday coming up. So I'm going to push this deadline. Don't worry about it. I'm going to push this. You should do 4.R.3 by this Sunday, but I'm going to push this one to next Friday. Well, next Thursday or Friday.
You mean 4R.3, right?
You can do 4.R.3 by Sunday. You already know enough to do that. But this one, I'm going to push to, what, the 26th, Friday? Just to kind of give you a heads up. Because we're not going to be able to do it till next Wednesday. And once we get here, this will be the end. This will be test 2. Okay? This is the material from test. So all the material from test 1 to test 2. To this line will be test 2. But that's not until 2 more weeks. So we're still got next week, and then we got a review leading up to that. Alrighty.
All right.
So you take the extra time tonight to work on homework, complete the lessons, and again, as always, just send me your questions. I'll be glad to help out. All right.
Thank you.
Okay. Well, hope you have a good one. Hope you have a good break for sure.
You as well.
And we'll catch up with each other on Wednesday.
Yep.
Wednesday. Yeah, Wednesday.
Yeah.
Yeah. Okay. And I'll post this video here shortly too.
Thank you.
Okay. Bye-bye.
Thank you.
Have a good night.
All right. Thank you.